All right, let's see if this works. So the goal here is to try to find a better accelerator message for the accelerator pedal and maybe the 2017 gas models. So people report that every once in a while it triggers and then deactivates ACC and OpenPilot because it thinks that the accelerator pedal is pressed. So here's a Cabana log, I think, from Crum Research. I'll load it up. First, we'll take a look. We'll skip forward a bit where it's actually driving. Take a look to see when OpenPilot's actually engaged, when adaptive cruise control is actually engaged. Or it's being slow. Try it again. I'll also pull up this one for PLP. Maybe that didn't work. Let's try this one. There we go. This happens at 12:26. So we'll skip over there. We'll load up the DVC for Pacifica. It's this one. The hybrid private fusion one is for the radar bus. You'll see it show up as CAN 1, but here we want it just on CAN 0 where all the main messages are. Takes a little while to load. All right, so we'll try this one. We'll load up the ACC. The message that we're actually using, I think, is an ACC2, ACC status 2. You see the description here, it's 1 and on ACC, 3, and so on, but it's 7 when ACC is actually engaged. So here we can see ACC status go up to 7 here, so we'll zoom in a little bit, and then it goes back down to 3, so it's canceled for something. So let's see if it's canceled because it thinks the accelerator pedal is actually pressed. Accelerator pedal message using is, yeah, this one here. Yep, so we can see here the accelerator pedal is being pressed. That's probably legitimate. And then here, this is probably the one causing the cancellation. That people are reporting they're not actually pressing it, that it's something to do with adaptive cruise control, but it's still, but then OpenPilot picks it up as a accelerator pedal press and then cancels it. And we can see that it's actually OpenPilot canceling it here by looking at what, like bus. So if it's sending a message on bus 0, then it adds 128 to it when it's actually the Panda sending it. So we'll look at bus 128 to see the messages being sent. So here it sends wheel buttons to actually cancel the adaptive cruise control. It'll send this ACC cancel button. So sure enough, we go down here and we can see that these messages, reset the segment, go back here, look at this cancellation just a little bit before it. So right around here at like say 240 something, showing up at like just after 241, the accelerator pedal hits. And then we start sending wheel button messages, sure enough, with the ACC cancel there. So yeah, it was OpenPilot canceling it because you can see the accelerator pedal message happening. Then we can see OpenPilot sending the wheel button with the ACC cancel. And then, as expected, the ACC status drops from 7 down to 3, meaning that adaptive cruise control is no longer turned on. So now the thing that we need to try to find is a message that is not being set in this area, but that is set when the user is actually pressing the accelerator pedal, or the gas pedal. So the rough strategy for that is we'll make another copy of this Cabana view, and we'll look for wheel speed to try to see where the user is actually accelerating. Let the messages load. Yeah, here we go. The Jeep one finally loaded. So we can do the same sort of process with the Jeep one here. The ACC2, we'll take a look at the ACC status 2. See it's 7. Oh yeah, and right over here it goes from 7 back down to 3. Let's see what the accel pedal is doing at that point. Sure enough, we get the same trigger there, the accelerator pedal. See if we can zoom in. All right. Sometimes it doesn't work when it's right at the end there. Now, let me check to make sure this is working. All right, yeah, it looks like the stream is streaming. Pull it up on here. Make sure it looks fine and everything. Yep, seems to be working. All right, cool. Quality looks reasonable. I'll try to make it better later on. Let's see, all right, so this is back to the Jeep that we're streaming here. Although it looks like my face is covering up some of the window that's actually useful there. So let me try to move my face. Should be able to move it. Where don't we care? Probably up over there is fine. Does that look any better? Yeah, we'll see. All right. So now this is the Jeep. Let's see, sure enough, right around this disengage time, you can see the accelerator pedal trigger, accel pedal, and then now let's see if it's OpenPilot also sending a cancel message. So we'll look at bus 128, which is just an indicator that OpenPilot is sending a CAN bus message out on CAN bus 0, but it shows up in Cabana and Panda and stuff as 128. So wheel buttons, so pause this. Sure enough, let's see, 409, we see ACC cancel, reset the segment. Yeah, it looks like it's about 409 where this is going on. 408, sure enough, yeah, 409.3. The accel pedal message hits, and then 409.42, the wheel button cancels, and then by 409.6 or whatever, the ACC status goes down. So the same sort of behavior, so we'll try to find a message that indicates that the accel pedal is actually being pressed, but doesn't trigger in this sort of time frame, and does not trigger here on the Pacifica in this time frame. So I'll come over here to this beginning of this drive, and we'll look at the speeds, because I don't really know when the user's pressing the pedal, but we can probably guess when they're accelerating pretty heavily that the user's pressing on it. So what about this segment here? This looks like a pretty good guess here. Maybe even this part right here, you can see they're accelerating pretty well. So now, let's see, I already have a bunch of messages defined. Might even be just a better value in this accel pedal message. So I'll play the game of trying to create messages here, and Cabana by dragging, you can see this is maybe some sort of, seems to correspond with how it's accelerating. So sometimes Cabana gets this backwards. You know, I was trying to drag it from there to there, but we'll just change the Indianness to fix up the actual order here. So I can plot this, you can see it's all crazy there. That's a sign that you don't actually have a correct signal unless it's a checksum or a counter or something. So I'll go ahead and change the Indianness here to big, and in order to actually refresh it, I have to go ahead and hide it and then show it again. Sure enough, this looks more like a real message, which is nice. I'll drag this down. One thing you notice, if it looks a little bit blocky here like this, where it steps up, that maybe you don't quite have all the bits in there, maybe you're just in the higher order bits. And sure enough here, if I drag, I can see all these extra bits moving quite quickly, as you'd expect in the low order bits, so I'll include those. Hide the plot, show the plot again. Sure enough, a nice smooth curve now that shows maybe something to do with the accelerator. And then even here, this message I'm using, this accel pedal message, you can see down here below it, there's lots of bits that are moving quite fast. So maybe I'm just sort of taking the higher order bit, and when you press it hard enough, it triggers. Now let's see, yeah, so you can sort of see here. One artifact you might see in the graphing here is, see, it looks like it's a nice low signal, then it jumps way up to the top. So either that means these are two separate signals, or we included a bit we shouldn't have, or in this case, maybe we're in fact cutting off a bit. So if we go here, sure enough, this next high bit is 1, but we're not actually including it. And so that's why it's getting this sort of jump there. If we change this to actually include it, so this is new signal 3, I'll go ahead and least significant bit, we'll move it up in the graph because the UI wasn't really working. Let's move it up to 38. Let's also then increase the size up to 10. And we'll hide the plot and show it again. Did that make it better? Not quite for some. Oh, yep, so it changed the Indianness. Let's change it to big Indianness. Show it again there. Now we have a slightly smoother message there. And now let's also reset the segment and take a look at what these signals look like at the very beginning. We can see some of these artifacts here. We have a nice smooth signal, but then we hit this max value here. It's kind of surprising. Which means the signal might not quite be right. But I do like this new signal 2, looks a lot better, where it actually goes along with maybe what's being pressed. Because when we're right here at the very beginning, the car is sitting still though, and it's right around 1,000 or 900 for some reason. So maybe this is not even the accelerator pedal, but maybe this is like engine RPM or something like that. For this, it would be nice to have an OpenPilot stream of the actual dashboard, or to maybe see the RPMs or something like that, to see what it's sending. So maybe this message is not the best one. So where can we find a different one? What other sort of, maybe the brake pedal one has something? So brake related, what are we using for brake? Brake pressed ACC, speed related, brake related 3. And now let's see, what brake are we actually using? Brake press 2 probably. All right, 5 when pressed by a human, 1 when ACC. Let's see if there is a value that corresponds with the accelerator pedal, the accel pedal, not just the brake. So let's clear these out. I don't really like these signals. They seem to be more RPM based because they have some nice values even at low speeds. Let's see when the brake is pressed. So sure enough, we can see 5. Because this is all human driving, there's no ACC enabled yet. If we come over to this drive where we're looking at the ACC, we pull up the same message, the same car, maybe brake 2 is what we're looking at. Yeah, brake 2 is what we're looking at here. Let's check the chat. Cool, so you can hear the stream. Awesome. Over here to brake 2, so maybe there's a better pedal message here. Maybe all this message is brake, or both pedals. Let's see. And sure enough, we can see brake press 2 here is 1, which is what I've documented here, that it's when adaptive cruise control brakes. And sure enough, that's what's going on here. This ACC is on, so it's probably braking. Now let's see if there's a time when. Let's see. So it's braking. Maybe there's something else going on here. Are there any values being set when ACC is accelerating? Let's take a look at wheel speed so we can see how fast we're moving. Oh, this whole segment we're braking, or at least not accelerating. Let's see if there's a time when we're accelerating with ACC on. So ACC is on around here. So no good candidates in this area. We're trying to find a place. It doesn't really stay engaged very long here, does it? Let's head over to this other drive. Is this the Jeep drive, it looks like? Let's see, ACC is on for a while here. Yeah, ACC is on for a good amount of time. Let's see if we can find a time when ACC is accelerating. Not particularly. Maybe you'll zoom back a little bit. Take a while to load. I need to maybe make some sort of light version of Cabana now that it's open source, or strip out most of the video and things like that, and maybe cache all the CAN bus messages locally to make this sort of analysis a lot faster, or to see whatever is actually being slow. All right, so that's accel pedal. All right, ACC status is nice and high here. Wheel speed's going up while ACC is on at 7. So this looks like a good area to see what messages, if it doesn't lag. All right, what messages would indicate acceleration from ACC? And then we can look for acceleration in a similar pattern as the brake, where there's a 5 and a 1. Maybe there's the same sort of set of bytes near each other as well. So where were we? Let's go to break 2 on CAN bus 0. And when you're doing this, make sure you don't hit CAN bus 130. That's like, well, you could, I guess. That's actually just OpenPilot sending a copy of all the CAN bus messages to the stock LCAS camera, so they can copy things like the counter and everything to keep the stock LCAS camera active, so it thinks that it's working. That way it'll send all the counters, and also it'll send things like auto high beam messages, where that Mobileye or whoever makes that LCAS camera on the Pacifica will say, hey, the screen's bright enough, or the display is bright enough, might as well go ahead and turn on auto high beams. Which is why we do that, but that's what all these 130 messages are. All right, here we are, break 2. So this is probably ACC accelerating. Now what do we see? Sure enough, all those are zeros there. And now if we go back to the other drive, looking at break 2, we'll see where the ACC is not accelerating, where it's a human accelerating. What's going on here? What sort of messages do you see? So we see 1 set there, we see a 1 down there. This is brake pressed ACC. So I wonder if either of these messages are good candidates. That 1 there and the 1 there. So those are both set for accelerating, but then this one is also set. Sort of compare it here. We have some the speed related one here that I have here, but this might look speed related is being set for human control. Let's see if the speed related is being set for ACC control. Yeah, it is. Let's see if any of these other ones are useful. Let's see what this message looks like. It's new signal 1. Yeah, it's just set the whole time to the same thing. We'll go over to this drive, the human drive here. So this is the ACC drive, this is the human drive. So you're basically looking for differences between them, but that also correspond with acceleration. We'll see if this is ever changing. No, that's not ever changing. What if we make it bigger and include these? Still is never changing in this segment, which is not good for, because the accelerator pedal is clearly not being pressed the whole time. Yeah, so maybe this doesn't actually have any good stuff here. This here's the counter and the checksum. While you're looking at these drives, if you ever wonder whether you have a counter, sort of an easy trick is plot it. Looks like this, which either means it's a bunch of noise or not, but you can zoom in and zoom in and zoom in, and sure enough we see this nice sort of a sine wave or step counter, whatever you'd call it, there. And then if we look at the checksum, we go and reset the segment, you can see it's sort of noisy here. If we zoom in, it looks a little bit like a counter, but it's sort of not quite random. Other drives that have real data will look a lot more random, but this one, because the input has a pattern, then you see the same sort of pattern emerge. All right, so this one maybe is not panning out with what we want for a human thing. A chat message. Does Cabana let you zoom in and out, scale the horizontal axis and plots? Yeah, so the horizontal axis in plots like this here, you basically click and drag. So here I'll hold down the mouse button, drag it over, and then it zooms in on this, and it zooms in all of these other graphs as well. And so I can, for example, reset segment. I'll delete these because there's no good data. For I'll hold click and drag in order to zoom in on the horizontal axis. It zooms in, so I can see there, and I could zoom in, say I wanted to look at this little dip here, and I'd see that little dip there is zoomed in. And you'll see this pixelation, this sort of stepping here, because those are the actual messages. They're only sent however often, so it doesn't look as smooth when you zoom in. Yep, yeah, zoom in by selecting, but I started click and dragging. All right, so that message did not look like a very good candidate from this drive. Let's try another one. Break related 3, what did I say about this? Nothing. Break 1, speed related. Yeah, it does look speed related, but let's see if any of these other bits are being set. No, yeah, most of these sort of things, break related 1, look like not binary messages, but sort of, measurements of things, so they're maybe not as good of candidates for it. Except for why is this nice and flat here at the 340? That seems suspicious. Maybe this is the pressure on the brake or something. Let's see if brake 1 is being set in the adaptive cruise control drive. No, not there. So actually maybe, that's interesting. Speed related is set, but the brake related is not. Except for here. Brake related 1, 2. Brake related 1, 2. So this is kind of interesting. No, I guess it sets it as well. I'll hide these little things we're looking at. Now remember, ACC status goes high here. Yeah, brake related actually drops off, even on times where it looks like it's probably braking. Oh, I guess it's tiny. Here we'll zoom in and see, yeah, some values there. So we'll go here, ACC is on, we're accelerating. So ACC acceleration is being set over here, and speed related. Speed related 1 here, yeah, follows just a nice graph of that, so it's probably, but it's all 0 there, but yeah, it's because it stopped. So another approach we can take if these existing brake messages don't work, so we're using brake press 2, let me verify that in the code. Just want to make sure that's the actual message we're using. So OpenPilot, self-driving, car, Chrysler, and then is it in car state? Not car state. Maybe interface, or maybe it is car state. Oh, yeah, here's car state. So the one we're using for brake press 2 inside brake 2. Sure enough is what we're setting as brake pressed, whether it's equal to 5 for human only. Because a lot of times the related messages are close to each other, similar to each other. So let's see, brake 2 is message ID 140. So let's see if there's any other messages like right next to it, like 1.3e or something, or 1.4.2. So 144, there's a speed 2, there's no 142, 141. Let's see if there's any other 130. There's 134, accelerator gas. So this must not be set in the hybrid that I look at, or maybe it is, let's see. Yeah, so this is acceleration, lines up nicely with the acceleration here. When it's accelerating, so that's kind of cool. Let's see, what did I say about it? Nothing. And here I suffixed it with 134 because it's the message ID 134. And Cabana, at least at the time when I was doing the reverse in the CAN bus messages, would overwrite other messages with the same exact name, even if they were within a message, I guess. So I suffix it so they're all globally unique just to avoid that issue. Now let's see, maybe this is promising. Let's see what accelgas134 looks like in the ACC drive. So here, ACC, accelerating somewhere around here. So accel here is not being set, so this is promising. Unless this is, let's zoom in here, so this is where it's being set. You can see here these artifacts make it look like it's being cut off. So it looks like we don't have the full message, I would guess. And sure enough, we can look right here. This next bit is 0. We go over here, see it goes way up and then drops down to 0. A lot of times that means that you're cutting off a high bit, and sure enough, this next bit is 1. So I'll include that bit, I'll hide the plot, show it again, and now it looks a little smoother, but we can see the same sort of thing seems to be happening here. We'll go over here, yeah, the next bit is 1. So we'll scoot it over and do it again. Now we do not see any more of those artifacts. So this is something we should probably update the DPC with. This accelgas message is not just 4 bits, but actually at least 6 bits, maybe 8 bits or more or whatever. It's hard to tell without pressing the pedal more or something or going there. All right, but now back on track. Speed related. So this is when ACC is off. So it's only sending this message when ACC is off, it looks like. Because we go over here where, luckily Cabana mostly lines these things up. Wherever your black line is when you click on it, it'll go over and do it. So yeah, right as soon as ACC goes up to 7, it stops sending this accel134 message, which is promising. So now if we reset the segment, all right, looks like I'll have to cut off the stream for now. We'll see who's at the door. But actually, let's see. All right, looks like that's it for now, but I'll have to play around with this message more, and I'll see you later.